Another good question here. 2021 Scholarship Calculus, question 3c. Consider the cubic function f of x equals ax cubed minus bx, where a and b are both positive real constants. F of x cuts the x-axis at the origin and also at the point of P and Q. Find the value of f prime 0 if the acute angle between the curve and the x-axis at point P and Q is equal to 45 degrees. Alright, if you want to try this out, pause this video and come back. Otherwise, I'm going to solve it now. Okay, over here, so I see this another simultaneous equations question. We have to find A and B, right? Then we should be able to answer this. So before we do that, I'm gonna draw this graph, so it would be easier to understand once I do that. So this is the situation, right? So this is y axis, x-axis 0 and negative square root of 3 and square root of 3. So what it's saying is the gradient of curve, that means gradient of tangent here, is 45 degrees. The gradient is 1, isn't it, at that moment, right? So same here, right? Because it says acute angle is 45 degrees. So meaning gradient is 1. And the question is, what about this? So it's tempting to say that's that doesn't look like a 45, but you might think, oh, that must be 45 here. That means gradient is negative 1. You know what? It's not, because this is a cubic graph. So unlike parabola is like a symmetrical, right? But this is not. So we don't know whether it's negative 1 or not. All right. So we have to find it out. So I see we can make one equation out of this. So if I plug, say start with square root of 3. So that means 3 square root of 3 a minus square root of 3b, right? So when you plug square root of 3, that is 0, isn't it? That's one equation. The other one is negative square root of 3. So that means negative 3 square root of 3a, and then plus square root of 3b equals 0. Well, I don't think this is equation number 1 and 2, because when you add them, you get nothing, right? So when you add, so you get rid of a, and then b disappears as well. So 0 equals 0. So no point. So we can use just one of them, either this or this. But I'm gonna choose this one as equation number 1. Okay, and then we have to use derivative to find the second equation. All right. So when we differentiate f of x, we get 3ax squared minus b, isn't it? And it says over here, when you plug, say, square root of 3, would be easier. What do you get? So that's a 3. So 3 times 3 is 9a minus b is how much? Gradient is 1, right? So that's second equation. So that means b must be what? 9a minus 1, right? So we can plug that into equation number 1, right? So that means 3 square root of 3a minus square root of 3 9a minus 1 equals 0. And we can solve for a. So 3 square root of 3a minus 9 square root of 3a, which is minus 6 square root of 3a, isn't it? And then plus square root of 3 equals 0. So I can divide by square root of 3 on both sides, leaves negative 6a plus 1 equals 0. So this means a is what? 1 over 6, isn't it? So knowing that a is 1 over 6, b must be 9 times 1 over 6 minus 1, which is 3 halves minus 1 is 2 halves, right? So it's a half. Okay. So what we have to know is the gradient when x is 0, right? So our aim is f prime 0. So knowing that, so this is, I'm gonna plug them in. So a is 1 6. So a half x squared minus b is a half as well. Right? Yeah, this is right. So when you plug 0 into this, what do you get? You get 0 minus half, which is minus half. So it turns out the gradient of this tangent is negative half. All right, that was fun. Okay, I'll see you next time. Bye.